Hello, NPC 46. How are you? Relearning rigging after 2 years of hiatus. That sounds rough/fun. Do you work at NPC, or does NPC stand for something else? Hello, apartment cartoons. So last time we left off here, we had used remap nodes to connect the translate Y and translate X of this master blink control to each of these individual sliders here. But I realized after thinking about it that it's probably cleaner to not use direct connections here and instead create a closest point on curve node for each of these vertical curves, and then parent some locators, one for each of them underneath this master control, so that wherever those 4 locators happen to be, it represents where they are, and then we can have a lot more freedom here, and it might solve some of the more complicated issues we were dealing with, and it also means we won't have to manually create a whole bunch of remap values. So I just saved this off into a new file, and I'm gonna go through and delete all those closest point nodes that we created. Let me find the ones that are attached here, make sure we grab everything. Yeah, I think the closest point node is really all we have to delete. So if I just select each of these curves, go into the attribute editor, and select them one by one and hit delete. Should have to do it twice for each one. There's that one. And that one. Okay, that should be all of them. Cool. Great. All disconnected. So now what I need to do is dig up one of my other scripts instead of the one we ran down here, which was for just attaching them to the curves rather than attaching and then being driven by a nearby locator. So I'm gonna, you won't see this for a second, it's on my other monitor. I'm just looking to find my attach to curve scripts. All right, I have one called curve attach driver. I'm assuming that's what we want. Whoa, it's a long command. All right, pasting it over here. All right, let's see what we gotta do here. So it's looping through all the offsets that we have selected. Hello, Animation Mob, welcome back. We're looping through these offsets that we have selected, which would be, let's see, kind of lost in the outliner because I just booted this up. Let's minimize everything, get our bearings. Okay, so it's these 4 that we want to attach for now. And the curve is going to be, I guess, one by one. Oh, yeah, so we'll start with number 3 just because it's the most prominent. So that one, and then number 3 here. replace the curve variable. We have driver and driven, which means we'll have to manually create our 4 locators first. Okay. So if we select these 4 controls and just create some locators at the center, grab them all and parent them to the blink control. You know what? Huh. Maybe this method is actually not the best, because we'd still have to create some remap nodes to get those to translate in a different way. Trying to remember why exactly I wanted to do this. Don't you need the start and end for each null object? Animation mob is asking. The start and end for each null object. I'm not sure what you mean by that. Can you elaborate? Locator. Yeah, I'm still not sure what you're asking. So these 4 locators are not riding along these curves. These are so that we can move these locators around, and then wherever the closest point on that curve is, that's where these lid controls will be on that curve. But I'm realizing that we'd have to create remap nodes for these 4 anyway, so it's kind of the same thing. So maybe we don't do this. So let me save this and reopen the last file and sort of reassess what we're trying to do here. Nope, wrong one. Okay, so back in this file, we had this whole system going, and we got these to match this nice fall off just by physically moving around the points on these curves here. But the whole process of like doing that moves the start point or the default point of each of these small lid controls. So in theory, it's really not a very clean way to do it. But I guess because at the end of the day, it's going to be part of my rebuildable rigging system, you could always adjust the curves, hit export data, and then when you rebuild it, the joints and these controls should jump back to their original locations. But it's still not the cleanest. In theory, the problem we're trying to solve is easily being able to adjust the shape that this sort of overall blink line makes as it travels from 0 to 1 on these curves, because 0 represents the very top of this NURBS curve, and 1 represents the bottom. So in theory, everything is just traveling from 0 to 1 along here, and that works fine. But if we zero out the remap value nodes that are actually driving, or do we have remap values? No, we just have point on curve. I thought okay, I guess we deleted the remap. So right now, each curve, 0 to 1, this control, we plugged in the highest point and the lowest point to each curve. And then the way we got it to make a nice blink line was just manually adjusting this, because like 0 to 1 is in relation to where the CVs are. So if we grabbed all these middle CVs, you see the like roughly 0.5 that it's sitting at right now. It lands somewhere else. Like even if we just grab one like this, like 0.5, let's just say for argument's sake 0.5 along this curve, like 50% is where this CV is. Wherever this CV lies is kind of the midpoint now. So by adjusting this, it does change the midpoint sort of in between area of what the blink looks like as it goes from 0 to 1. But by default, these curves looked pretty sloppy. Like, not the curves sloppy, the blink line looked sloppy because each of these hitting roughly 50% just didn't make a clean blink line. So it really does come down to where you place these curves and where each of their CVs are located. Which means I don't think there's a way around being able to adjust this in real time with the default points starting and ending. I mean, as long as you're doing it before you skin it, it's not the most important thing in the world because it's still more or less going to give you a similar result, but it's not the best. It's not the best. Let me think about this. Animation Mob says, what if you set the locator to the path, then it would be 0 to 1. I'm not sure if you were following what we were actually trying to do, which is not your fault. I was just kind of messing around. But I think we're far enough away from that concept at this point. I don't think we're actually going to do that. There would have been benefits to it, but at the end of the day, I think it just made it too complicated. So the one area where we do have remap nodes, I think, is in moving this left to right. Oh, I know where the remap nodes are. Okay. Yeah, the remap nodes were plugged into the plus minus average node. So if we select that plus minus average node, we'll see 2 remaps. Okay. So yeah, we've got the X and the Y remap. So either way, even if we did it the other way where we just had some locators telling it, you know, wherever this locator is, that's where the joint is going to be sliding at any given moment, we'd still have the same number of remap nodes, so we'll just keep it clean and use it in this way. Just trying to think if there's some way to adjust the shape that it hits as an in-between, like at 50% roughly, without having to adjust what these curves look like, because that'll always change their default position. And the only reason it changes their default position is because no model is ever modeled with the lid as far open as we want the rig to be able to open. So the highest point that this character can open their eyes, we want to be pretty far back in case the animator wants to really push it. But it makes no sense to model a character like that, which means the default position will never be 0 or 1 on this vertical slider. Does that make sense? Which means that anytime we adjust how it looks in an in-between state, this arbitrary point that it sits at, which looks like, you know, it's like 0.15 or something, that 15% along, not 0.15, but like, 0.15, like 15%, that arbitrary point is going to change. So one thing we tried earlier was looking at the actual remap value nodes that determine at what values this translation drives the other one, which in this case, it's like it needs to go, like it's between like 1.6 and -6 or something like that, just based on where the curve happens to be in space in relation to this translational control. And so there's always a remap node in there. Where is it? So there's always a translate Y remap node saying when that yellow control is translating from 1.476 to -6.135, move the position of this little control here on the curve from 0 to 1. 0, 1. Except, you know, sliding on the curve. And one thing we experimented with is adjusting that actual remap value node like so, with the actual like graph value here. So this is like the remap value saying as that yellow blink control goes up and down, go from 0 to 1 on the curve. Slide from 0 to 1 on this vertical curve here. And so let's say we're at roughly 50% down the blink. If we adjust this middle point on the graph, you'll see that determines where it lands. But even in doing this, I think it still adjusts. It's still gonna move the default position of this control. So if we leave this at default and then adjust this, it still moves. So either way, it doesn't solve the problem. You know what might solve it? I don't know if this is possible. I'm just thinking out loud here. Please let me know if you have any ideas. I don't think there would be a way to do this. So right now our curve parameter that we're sliding the little red controls up and down go from literally 0 to literally 1, tip to tip. But if we weren't setting the parameter to be 0 to 1, if it was arbitrary, like, 0 to 4 or whatever this curve happened to be when it was built, I think it might be 0 to 3. If there was a way to say, like, this is 0, and before 0, it's like a negative. And then we could adjust the graph. Maybe, okay, ignore what I'm saying. So we've got this graph here, and it goes from 0 to 1. And the default is not 0. The default is, and we can actually just look at the point on curve node to see what it's currently at. 0.194. Interesting. Okay. How do I, like, is there a shortcut to, like, get back to this node? Let's copy that. So we know 0.194 is the default position that this little, and I'll actually just isolate stuff so you can see what I'm talking about better. Okay. So when translate y of this is at 0, we know that, let's get back to that remap. Okay, here we go. So when translate y of the yellow control is at 0, the point on the curve that the red control falls is 0.194. So if we look at the way this graph works, I believe left to right represents the driver and vertical represents driven. So as the yellow control goes from negative 1.5 or whatever it was to negative 6 or whatever, the translational range of the yellow control, at one point on here, somewhere around here, 0.194 is where it lands. So let's close out the big one just because it loses these little values here. So if we add a second point on here and say that, so this position is horizontal, vertical is value. So the selected position of, no, I guess it doesn't take into account the number. I guess we'd actually have to do math to figure out what percent or what fraction of 1 this position falls at. Which is different than where it's different than where this one, or it's different than where this one happens to be. Like, for any of our vertical blink curves, it's unrelated to where this particular blink control happens to be sitting. These two just happen to be a close match, so that doesn't actually matter. What does matter is figuring out, damn, this is complicated. I keep thinking I solve it, and then I don't. So what we need to figure out is, on a path, or on a linear counting layout. I don't know what the math term is. I'm probably confusing all of you right now. Let me try to bake this down. Right now, and I would potentially script this all out to be automatic. We need to trying to find what I'm looking for here. Okay, so we're back to the remap value that says from what positive and negative values this yellow blink control moves. We need to figure out on that path of 1.476 to negative 6.135, where 0.194 lands on it? I am lost. I'm lost in my own head. I wish I took more math classes in my life. Animation Mob says, are you trying to get something like 0 to 1 are your limits, but have inner limits 0.2 to 0.8? Or are your new 0 to 1? I'm sorry, I'm having a really hard time understanding the question. This is such an abstract concept. Let me try to describe what I'm doing again here. So there is a remap value node. And it always takes a couple seconds to find it because of this plus minus average. Okay, so there's a remap value node right here. Oh, it was right here, duh. Whoops. So we've got this remap value node here. And it's saying, as the yellow control translates from this point, the very top of the curve, roughly, because it's, you know, it's just chilling in space. As that yellow control roughly translates from this area up here, so the control I have selected, the big guitar pick looking one, as this one translates in Y from here to here, which is literally 1.476 to negative 6.135, if we can figure out what exact translate Y value when converted to 0 to 1, like a percent, this one happens to be right now. It's really, maybe it's not as complicated as my brain is trying to make it right now. Because ultimately what I want to do is I want to drop 2 extra points on this graph right here on the right side of the screen that I'm moving around. If we drop a point here and we drop a point here, we then know that the tip of the curve is that furthest one, the base of the curve is this other one, and then we know exactly where these fall. Let's just, you know, we'll eyeball them for now. Or, yeah, maybe we don't need that second one, but either way, it's probably fine. Where is it? So let's just kill this one for the sake of explanation. So basically what I want to do is have an extra point on my graph here that perfectly represents where our little red control here lands on the curve in default. So if we just eyeball it, so let's delete it and then try to eyeball it a little bit. So roughly around there represents where it's supposed to be. So if we put a point on the graph there, it means if we add other ones, that first one isn't going to move. So we can adjust what it looks like when it's roughly halfway down or 2/3 of the way down without changing its default position. So I'm trying to figure out how to use math to get that actual value that we can plug in to this selected position. Okay. So I think the math is starting to form in my head as far as actually being able to explain what I'm trying to do to you. Apologies for how complicated this is. Hey, show me. Okay. So we have this extra graph point that we added here. And what we need to figure out, ignore the red control for now. What we need to figure out is what percent. What we need to figure out is, damn, this is so hard to explain. Okay. So I don't know the math term for this, but the the plot of math land, the plot of numbers that go from 1.476 to negative 6.135, what is the percent of that range that 0 falls on? And that might actually not be that complicated. Ooh, we got a spammer in the chat. Time to ban. Okay. Let me just see what Animation Mob's saying here. In Softimage, there is like these distance calculators. I'm sure Maya has them too. Maya has distance, but this isn't about distance. So what I'm saying here, and let me just like open up a Word document or something. And maybe someone mathy in the chat will have some advice, because it honestly might just be a simple like subtraction or something. Or maybe it's just a, yeah, maybe I'll draw it in Photoshop. Okay, so here we are in Photoshop. And we've got a bunch of numbers here. And our numbers are, or the range of these numbers go from 1.23. Oh wait, is this, am I looking at the right thing here? Did that change or something? I could have sworn that was a different number before. Yeah, it used to be 1.4. What happened? Did we accidentally? Okay, whatever. Now it says 1.4 again. That's what we want. So 1.476 to negative 6.135. And that's what this graph, this horizontal graph represents. 1.476 through negative 6.135, just counting in a linear way, although it's opposite just because it happens to start with a positive number. So that's what all of this is. Does that make sense? And the thing is that our control, our big yellow control, has a default 0 value of where, like, or in simpler terms, on this graph, 0 is literally somewhere around here, right? So if you just start at 1.476 and start driving along this line to get to negative 0.135, 0 falls somewhere here. And what we need to figure out, and this honestly is probably the simplest math thing ever, if literally anyone has taken like more than one college math class, you probably have the answer right now. Also, this is, just realized this is not showing correctly on the monitor. Okay, there we go. So, thanks for the follow, Brody, and hello, Pierre. We are doing some probably very simple math that's just confusing the hell out of me right now. Basically, we have this linear line that goes from 1.476 over to negative 6.135, and what we want to find out is where 0 falls on this, what percentage of the way from this number to this number that falls. Spidey asks, am I trying to normalize my distribution, change the range to something like a negative 1 to 1 or 0 to 1? If you're asking, do I want to remap it? No, we're already doing that. What I want to figure out right now, and it doesn't really matter why, that'll just confuse you, is along the path of 1.4 to negative 6.1, what percentage of that range is 0 at? Does that make sense? So I wonder if maybe it's just as simple as getting the total number that this represents, which I think is like I could just do subtraction or something to figure that out. This is so embarrassing. You're seeing how absolutely awful I am at math. So we need to figure out what the total number is between 1.4 and negative 6.1, and then saying, no, maybe that doesn't give it to us. Spidey says that should be total left divided by total left plus total right. Let me see what that gives us. Oh no, my armrest fell. Math. All right, so total left 1.476 divided by, can I not add parentheses in this thing? But yeah, I'm not sure if PEMDAS will allow me to just, I'll just do the right one and then the left one. So total left plus total right. Expand the calculator, will that do it? Where's the expand button? Nope, that made it littler. Is there a scientific calculator? Maybe we have to do that. Yeah, there we go. It looks, wait, so negative 0.1360 is about 80.6%, and since we're starting positive and counting to negative, if that's accurate, then that would be 19.4%. That sounds right. So let me see how you got that. So 1.476 divided by 1.476 plus, nope, that's not plus. No! Backspace deleted the whole thing. God damn it. Silly calculator. Wait, backspace works there. Why didn't it work earlier? 1.476 divided by parentheses 1.476 plus negative, or yeah, minus 6.135. Negative 4.6 is what I got from that. So where did you get 80.6% from? So this negative 4.659 should be the, wait a second, that number doesn't seem right. If we're counting from 1, let's get rid of the decimals. If we're counting from 1 to negative 6, actually, yeah, maybe that, no, that doesn't sound right. Counting from 1 to negative 6, or sorry, counting, yeah. Or let's make it simpler and reverse it. Counting from negative 6 to 1. Okay, yes, this number does make sense. This number is accurate. Okay. So counting from 1.4 to negative 6.1, we get 4.6. So that is the total number. And so what math are you using, Spidey, to figure out where at what percentage of that 0 lands? Your denominator was 1.476 plus 6.135. But our number is negative 6.135, so I think that might make it a little bit different. Right? I'm so confused now. I literally have no idea to find out. I completely don't understand where the percentage number is coming from. This is not the most fun part to do on a stream. I wish the Maya graph would just let us plug in the actual values instead of a percentage. Wait a second. No, that doesn't make sense. It's still 6.135 units to the negative side, plus the 1.476 units in the positive side. You want total units on the bottom. Yes, I want total units. Oh, I think I see what you're saying. So... No, I'm lost. I'm sorry. I'm so dumb when it comes to math. I probably should have understood what you were saying by now, Spidey. But I'm still lost. So in my mind, we did this calculation to get negative, or not negative, but we found out that 4.65 is the amount of total units we are counting between these two numbers. But I'm still completely lost on where we're going from there. Now that I have that number, what is the equation to find out where 0 is? The only equation I've seen written out is how to find the total numbers. I must be missing something. Wonder if there's a way... I wish there was a way to tell this graph to show me that actual range of like 1.4 to -6, whatever. But instead it always converts it to 0 to 1. So we found out how many total units there are. Maybe we have to... Yeah, if we subtract... Okay, I might be starting to understand this. So if we have 4.659 and we subtract 1.476 from that, that should tell us... how much of the 4.6 represents this left half. So let me... 4.659, let me draw some more stuff. 4.659 is the total length. And if we do 4.659 minus 6, wait, minus 1.476, that means 3.183 is, right 0 there. And what was that number I just got? 3.183 is this. And then the opposite is 1.476. Is this right? Alright, Spidey88's dropping some more knowledge that I'm probably too dumb to understand, but let's try. If you are trying to move from 1.476... Oh wait, 1.476, that's the number we had up there. I must have done something wrong here. Hold up. Let me just erase that. Where are my brackets? There. So if you're trying, so if you're trying to move from 1.476 to -6.135 using a 0 to 1 calculation, then you'd multiply your value, the 0 to 1 value, by negative 7.611, which I'm assuming is when you add these two together, and add 1.476. Okay, that's starting to make a little sense. Pure Elliott, yes, the 7.611 is 100%. That makes sense. Okay, okay, we're getting somewhere. So a position of 0 is 1.476, and a position of 1. Oh, so maybe my number was right? There must be some magic math stuff going on for these two numbers to be the exact same. Oh. Wow, is it really that simple that... Wait a second. So is it really a matter of just taking the first or last value and just saying what percentage that is of the full range? Let me try that out. So the full range is, wait a second, how did I get 4 point, yes, 4 point, okay, that is the full range, right. 4.659 divided by 1.476. I got 3.15. And wait a second. I'm bad with percentage calculators. Let me open up my handy dandy percentage calculator website. So now we just need to ask it 1.476 is what percentage of 4.659. Yeah, that is what I got. 31%. Is 1 really 31% of, is 0 really 31% of this? Did you guys get this 31.6 number somewhere in chat here? Divide at the end by 7.6 is what chat is saying. Oh, the full range is 7.611. Did I get this bottom number completely wrong? That doesn't sound right to me. Maybe it makes more sense in my brain if I reverse these numbers. Whoops. If I say we're counting, just so we're going up. Counting from negative 1.4 to 6. Yeah, that's definitely 7. How did I get this? How did I get this 4 number here? Now I'm gonna have to rewind and chat and figure out how we figured out the total number. I think the total number is just 6.135 plus a positive version of this first number. So yeah. 6 plus 1 is 7, 4 plus 1 is 5, and the extras, so yeah, 7.611. Okay, sorry for my slowness, we're getting there, I'm starting to understand it. So, this isn't right. The 1.476, and then, okay, this whole thing was completely pointless, because the numbers are literally... It's helping me to write them out counting from negative to positive, so it's literally just these two as these, and then the total number is 7.611. I'm just believing you in chat. I didn't actually add those perfectly right now. And then we just need to, in a percentage calculator, and it'll tell me what the equation is so I can stop being a terrible person and using this silly website. 1.476 is what percent of 7.611. We're learning math today. 19.39%. Is that right, chat? Is 19.39% what somebody got earlier? Scrolling up to find that. I am failing at finding the earlier chats, but Pierre Elliott says yes, so I am going to assume that's right. And we can test it out of Maya right now. So let's copy like 3 digits worth, 1.392. And also, the actual equation is literally just dividing it and then shifting the digit right by 2. So all of this was just to like see if this is the right way to go. So this is where 1 should be. Wait, 19. Oh, right. We actually want the digit version. It's so 0.193 on the horizontal area of this graph. And selected value is literally what is this value? I feel like there's a value on a remap node somewhere that I'm forgetting about. What do we have here? I think the output is that what we want? I'm kind of forgetting what we actually did here. So that's at 0. Maybe we're looking what... Oh, right, we need to look at the actual parameter. Where on the curve is it placed right now at 0? There we go, 0.203. Oh, wait. We want 0.203 before we create that graph, though. So let's get rid of that, see what the value is. Where is that node? Okay, 0.194. So we added a little thing here, 0.194. Or wait, no, we wanted that in the second one. 0.194, and the first one was our calculation of... It's almost exactly the same. Is that a coincidence that they're almost exactly the same? 0.1939? Huh. Okay. That can't be a coincidence, right? That after all that calculation, it gives us basically the exact same number for each of these. So that means if we... Oh my god, I am so dumb. The reason it's the exact number is because it's literally a straight line. I mean, that saves us a lot of hassle, but oh my god. All that math was to realize that literally wherever on here we place a number, if we put the same number into both of them... Wait a second. Okay. I understand now. So selected value will always be the same as selected position, but we did need to do the math because we needed to figure out where horizontally to place this. And we found out it was 0.139, or sorry, 19, what was it? Yeah, 0.1392 or whatever, and I'll just put 1.139, and then you just copy that over to the next one, and that makes it stay in a straight line, which is what we wanted. Okay, it makes sense. It makes sense. We're getting somewhere. So now we have a graph point placed. That means no matter what else we do to the rest of this, when it's at 1, or sorry, when it's at 0, it should stay put. But wait, why isn't it staying put? What happened? When this is at 0, what the hell? Why is it moving? I thought this was 0. Huh. Okay, now I'm confused. Because with this here, with this at 0, and this new graph point, if that number is actually where... Wait a second, am I using the wrong number here? Oh, sorry. I was looking at the wrong thing. It's 0.1939. I put the wrong number in. Come on. 0.1939 for both. And yeah, 0.194 is what it was saying earlier. Okay, now, there we go. Now we can do whatever we want to the midsection of this blink without it affecting its default position or anything before it. Now, in theory, we might want to figure out where it hits the bottom lid, but I don't really think so. I think it's more about just winging it with the graph at this point. So now, we want to adjust where this falls around this midsection here. We can just move this around like so. Set it to be spline. Set them all to be spline. Let's say we want it to be a little higher up, make it dip there. I mean, that works. It's just a matter of eyeballing it. Let's see it with the rest of it. So I'll go in and reset. What do I need to reset to get this back to default? Is this all going linear right now, or did I adjust something already? So the remap is at default. Oh, right, it's because I changed the shape of these curves. So we'll have to rebuild these curves and reattach if we want to see the actual original result of this. But either way, we know that now works. All we wanted to do was make sure we can adjust how these little blink controls travel along these curves without them changing their default positions. And it seems like we succeeded at that. We just need to do some math when I actually script this out to just plop that number right into that actual remap graph to make sure it stays put. And then we can manually adjust these. I guess when I script it out, I should have it manually turn all these graph curves into spline and add one extra here, because I don't know if I have it scripted out to like always rebuild every single manual curve that's or graph point that's added. But either way, it works for this file. But it already kind of did anyway. We just needed to rebuild these curves. Maybe for the sake of the test, we should reattach all these, but I don't really feel like doing it. So we know it works. Thank you for all the math help. I couldn't have done that without you, chat. Let's just delete these middle ones just because we had already kind of MacGyvered the whole thing to work without it anyway. So our curves are just kind of where they need to be right now. Okay, so this is what we had yesterday, and that's totally fine. But when I actually script it out, we'll drop that math in and make it more user-friendly. Yes, that one looks so high up. Okay. Now, do we want to do the same thing for the creases, I wonder? I guess. And I've also thought about maybe doing an auto-crease where these crease controls automatically lift up and down along their curves, depending on where the blink line is. Make them a little bit more fleshy. And I guess to do that, I'm trying to think. We could, in theory, just take the parameter that determines where these blink controls fall, and just copy them over with like a multiply node to be like 50% or 20% or whatever, which would be controlled by the animator. I guess we'll have to convert it to percent. No, but that doesn't make sense because they start out on different positions there. Yeah, I guess when I create remap nodes for them, I just query what their default position is and just set it to be... This is where, if we had actually gone through with doing the whole closest point method instead of remaps, this would be simpler. So we'd have like the translate y value, or the translate y negative value and the translate y positive value. And I guess that would have to be a condition node. I'm trying to think if there's a simpler way to do that though. Oh, right, we could do the same thing as before. Yeah, I guess that makes sense. We could do pretty much the exact same thing as before, where we just grab that value of this actual translate y value of like 1.4 and negative 6 point whatever. Plug that into a single remap node. And then have that remap node be multiplied by an arbitrary value that the user controls. Let's just add it onto the blink. Call it auto-crease. Or maybe instead of calling these like lid crease, we should call it lid flesh or something. But yeah, we'll just call this auto flesh for now. Make it a float from 0 to 1. Default value, like 0.35 or something. So it doesn't really matter. Default value just means when it's created. You can change anytime after that. Alright, so I got an auto flush value there. And now we have to grab, I'll just duplicate the existing remap node for this one, I believe. So this is a remap node that goes from, wait, that's not what we want. Where's the remap that says from negative whatever to, confused, 1 to negative 6? That's not it. That's weird. I think that one that we duplicated just got confused or something. Oh, that's right, I understand. I was forgetting that there's separate translate y minimum and maximum for each curve. So we want the one for number 3, which I believe is this one, yes. Okay. So here's this guy, and we already have the full extent of where this control needs to move. And we've got 0 to 1. Oh, you know what? You know what I just realized? Because the default value is not 1, that means when we lower that percent, Pierre Elliott says I didn't freeze. Am I frozen on stream or something? Is that what you mean? Or do you mean freeze transformations on something? We can't really freeze transformations, like that won't help us right now, because we're dealing with a default position on the curve that is not, like it's not a 0 anywhere, because 0 on the curve is always the very top tip, which is not the neutral position that the character is modeled in. So freeze transformations is not what will solve any of this. So let me just see what happens when I plug this in as I was playing to set it up, and I'm pretty sure we'll see that if we have auto blink set to anything, maybe we need to do that same trick where we figure out the percent. This is kind of complicated, actually. Maybe. Damn. It gets so complicated when your starting point is not 0. It, like, wrecks everything. But, and anyway, let's just plug this in, see how it goes. Don't think it's gonna work, but we'll see. So translate Y of our blink control. And the output will be this point on curve info node for the crease. Where is it? There it is. Drop it into parameter. Okay. So it goes from 0 to 1, just like the other one. Makes sense, but it's at a different start position. So maybe we just need to drop in another, and honestly, I'll just eyeball it for the sake of the test. No, and it's not linear anymore. Maybe it's about just changing the values of the remap. Like maybe if we like shifted these values all in one direction or something. Like what if this was 1.3 and this was negative 6.3. It shifted a tiny bit. Because the complicated part is that it's like we want all these to move along the same path, which also share the same 0 to 1 position parameter. But we need it to like stop when it gets to the top. Let me just subtract like 0.5 from each of these or something. So can I just type like minus 0.5 here? I know there's a way to do that. How do I do math in the channel box? Equals? No. Let me Google channel box math. I do not remember how to do that.
Go back, so you have to start.
Adrian says, don't look at me. I went to art school, not smart school. Oh, you put a plus or minus at the beginning. Plus 0.5? Nope, that didn't do anything. Syntax error. Let me see. Plus equals. Plus equals 0.5? Okay, that worked. Yeah, maybe we do want plus. Plus equals 0.5. And then same thing here. Well, that didn't work at all. We need to subtract for sure. Let's subtract 2 from each one. Well, that didn't work. How about minus equals 1? That didn't work. Oops. Minus equals 1. What about minus equals 0.8? Even less. Minus equals 0.6. There we go. And I guess we have to do it for both, so it still goes in a straight line. Wait, what did I do? Did I do 0.6? There we go. Perfect. So that works, but my theory is, oh, actually, maybe it is working, because I just realized, oh, right, we didn't do the multiplier yet. So I have a theory that once we drop the multiply node in here, unless it's set to anything but 1, it's going to change that start position. So we got that one, and then we've got auto flesh. And then take the output of that and put it here. Yeah, as I thought, unless auto flesh is set to 1, it's going to change that fall off point. So I think what we actually want to connect it to, I think what we actually want to do is drop in an arbitrary graph point like we did before to pin down that 0 position, which isn't perfect. I'm just eyeballing it for the sake of time and testing. And then what we want to do is have the multiply node control this value here on this actual graph. I think that'll work. So let me put this multiply node first. I don't know if I have to, it just kind of makes sense to me. Have the multiply node, or not the multiply node. I mean, okay, so it's not the multiply node there. I think what I need to do is plug auto flesh. Maybe we don't need to multiply node at all. We'll see. We need to plug auto flesh into this actual selected value of this graph point. Now, how do we do that? Let's see here. Value. Okay, so we have value 0, value 1, value 2. Value 2, float value. That's it. So let's plug auto flesh directly into that. Interesting. Oh, okay, wait. I guess they just go in order of created, so I guess we have to do this one. Okay. What happens when we set auto flesh to 0.5? Perfect. That's what we wanted. Oh, but you know, we also have to worry about going backwards. Shit. Well, let's just do this for now and see how it goes. So I don't think we need a multiply node here anymore. Okay. Wait, what? That's probably just because we didn't get the actual math pinpoint precision accurate on this one. Okay, that's close. And then when we adjust auto flesh, yeah, this is so complicated. Thought this was going to be simpler. So maybe we should figure out, like we did last time, where this one actually falls on here. Let's bring this back up to 1 just for simplicity. We need to figure out where this one falls at its default value. Now I have to remember how we did that. So I think we add the full range together. So we've got, if it's just kind of roughly placed there, but 0.876 plus 6.735. That means our total range is 7.611. And then we just divide that by the little number there, 0.876. And we've got 8.6%. So I think, do we just shift? What do we do here? I think we just shift the, no, that doesn't make sense. Not 8.6%, or is it? Is it 8.6? I guess that looks like it's about 1/10. And then let me just bring up the percentage calculator again, make sure I'm doing this right. Maybe it was the opposite of that. Was it 7.611 divided by 6.735? 1.11. Or if we shift the decimal, 0.113. Let's try that. 0.113. 0.113. Yeah, I think that's right. Yeah, I think we're good on that part. Okay, so we've got our graph here. We plugged in that value, and I think we also already plugged. Yeah, that's plugged in too. So let's see what happens if we put auto flesh at 0.5. Okay, the default position stays. Okay, that's exactly what we wanted. But now we need to figure out when it slides up. So auto flash is at 0.5. What do we need to do to this first value to get it to slide properly? So let's bring this up to like half of that. So in theory, we want that one to move half as much. So what happens when we slide this up? Maybe we need a remap node that goes to a maximum number of that. What? So like what happens if we put this as a value? Will that stay put there? Okay, that makes sense. So basically we need a remap value node that multiplies that number by, or maybe the inverse of that number by the auto flesh attribute. Okay. Although this is already a remap. I guess, yeah, I think we need a different remap. So we've got a different remap here. And on this one, it's just going to be normal graph. Standard. And our range is going to be, let's just reset it for now. Let's get our bearings. So this is going to take, what is this going to do? I'm losing it. Too much math. Selected value. This one. What is the driver value that we want here? We know the gonna be a multiply in here somewhere. Huh. So we know that the translate y of this is gonna be, no, that doesn't matter anymore. I'm losing my train of thought here. I need to create like an overlay that I can click on for my streams that just say, Josh is thinking in silence. So our goal is to drive this selected value right here, highlighted in blue. It has something to do with a remap that my brain realized earlier. A remap from 0 to 0.113. 0.113. But what's driving that? Maybe we need to drive it with the translate y of the blink. Yeah. And it's going to go from 0 to whatever the high value is there. So 0.8. Is that right? 0.876? Wait, what is this one? No, not that. What is the highest point this one reaches? Wait. What the heck am I looking at here? The 0.476 number. So 0.1476 translates into 0 to 0.113, and then we need a multiply node to multiply it by the auto flesh value. And then this will drive value 0. Why isn't that letting me? Oh, output X. Did that work? Oh, uh-oh, it's like inverting for some reason. Like at a certain point it's inverting. That's weird. What did I do? What is... Auto flush is set to 0.5 right now. What happens if that's set to 1? staying at 0 for some reason. What did I do wrong here? Wait, what did I... Is that auto flash? Why does it say 0 and 1 for auto flash if auto flash is at 0.5? Oh wait, auto flash is at 1. What the hell happened? Auto flash is at 1, which means it should be moving 100% with it. So if I move this slightly north, we get 0.35. Is that what we left it at? No, 0.453. So 0.453 on a scale of 0 to 0.4. 0, that gets multiplied by 1. So we've got 0.035. I think that makes sense. Why isn't it at 0 when it gets to that point? Maybe I feel like the translate Y thing isn't supposed to be in here. I feel like this auto flash was that's not supposed to happen. What is supposed to be calculated here? Undo that. Yeah, there's some logic is broken here. Should have named these nodes. I'm getting lost. So we made a remap node here. It says when you're translating vertically. Yeah, I feel like we don't. I feel like that's not how it's supposed to be done. Yeah, I don't think this is right. Let's delete these connections. So the multiply node we definitely need. We definitely want auto flash connected to this new multiply, but that's being multiplied by what? To get this value. Oh yeah, the translate Y of the blink does not matter here at all. We don't want this graph to change based on the position of it. It's kind of a cyclical thing. What we want is just, depending what auto flash is set to, maybe we just drop that value into it. 0.113. Sounds right. Is auto flash at 0 right now? No. What the heck? Maybe we need to invert it. Maybe I just type a negative here. I think that is not set to linear or something. Looks weird. No? Did I accidentally add an extra? The heck? No, that's not right. Negative number there doesn't work. We need the negative version of wait. We need to flip it. Use a reverse node on auto flash. Okay, that might work. All right. Okay, that's promising. It's perfectly moving along with it now. So now what happens if we set auto flesh 0.5? Okay, it stayed put. Moves half as much, but then stops. I guess kinda, I guess that's fine, because it's like we hit it at that point anyway. In theory, you'd want it to keep going. I wonder if we can set this graph to a negative number. But whatever. I think that's fine for now. Jix Design says, do you want the auto flesh to pass through a color blend or something of that nature? I think it would be pretty similar to what we're doing right now. I'm sure there's a way to do it with blend colors. Maybe you're onto something. I don't know if I'll be able to sort through that question live right now, but maybe later I'll think back on how we did this and compare it to maybe a blend color scenario where it's just finding the midpoint of all of it. Right now my brain's kind of just stuck on following through on this, which seems to work fine. What happens if we set auto flesh to 0? Uh-oh, that's not good. The vertical part's working, but the down part is not working. 0.113, wait. Why do we have 0.113? Oh wait, that's the wrong one selected, sorry. So that's set to 0 right now. I guess we don't want it to be set to 0, we want it to be set to the default, which is... This is so complicated. I don't know if I'm gonna, like, use this method. This is so complicated. There must be a simpler way to do all this. Multiply, divide. So auto flesh is directly connected. I think we need to say, we need a remap in between here that says that auto flesh goes from 0 to 1. It's actually going from 0.113 to 1. Let's... Oh, we've got an extra remap just sitting here that we're not using anyway. So when it goes from 0 to 1, go from 0 to 0.113. Actually, that's already what we were doing here. So pipe this into here. What happened? Zero to 1. Oh, right. 0.113 to 1. There we go. Now it's a straight line on the graph. Okay, so auto flesh is at 0. Nothing happens. It's all manual. And then auto flesh to 1. It's shifted a little bit. That's fine. Auto flesh to 1 totally follows along with it. Auto flesh somewhere in the middle. It works. Now the question is, and it doesn't really matter, but in theory, I don't want it to stop the second it hits that point, and I'm not sure why it's doing that. It's fine that it does, like, that's totally fine, but also you would never set this to 0.5. Like, having the upper lid line come down halfway whenever you blink is way too much. So let's see what happens when we set auto flesh to like 0.2. Okay, that looks a bit better. Of course, it would be all these eventually. We're just worrying about one at a time right now, though. And then when you go up, yeah, it's still... The up part, I feel like, needs to be set to a value of 0 somewhere here. Like, so the up value is the negative part here. I feel like if I broke this, set it to 0, that's what we would want. Or, It's like this full range is the translate Y, and this is set to 0.876. Where is it getting 0.876 from? Oh, right, we subtracted some manually. Oh, maybe we need to drop these values back to what they used to were now that we've changed some stuff. Let's try dropping these values into here. Seems to have moved. Might need to redo that math. Okay, that's the behavior we want. We just need to change this point right here to be somewhere. And I guess I can just eyeball it for now. Let's see, auto flush 0, auto flush 1. Let's just find a spot for this. And then copy this value maybe. Like here. And here. I'm gonna completely forget everything we're doing here because this is complicated. But when I go script it out, it should work better. It doesn't move perfectly, but maybe that's just part of it. But no, auto flush is set to 1. This doesn't make sense. No, this doesn't work. I feel like I'm gonna have to come up with a different way to do this. This is just so complicated. There must be a simpler way. But I think we're just gonna call it there for today because my brain is kind of fried trying to figure this out. We definitely figured some stuff out. Thank you for all the math help. But yeah, I need to kind of figure out a different way to do this, kind of just think on it without streaming for a bit. Let's hit the credits. Thanks for the follow, Brody G3D. And I'll see y'all later.